but I think you only set up again. So yeah, as is calling yani. As is calling still. Yeah,
Yeah, okay. Molweni, everyone. Thank you for joining us for today's session. My name is Onile Nkangezi, and so today I will be covering trigonometry, mainly focusing on curriculum grade 11. But first thing first, what I want to cover before we dive straight into it is the concept of a unit circle. So what is a unit circle? So basically, unit circle is a circle with radius of 1 unit, hence to a unit circle. Yeah. So let's draw a circle.
pen.
Yeah. Okay. So let's just draw the unit circle. First we just draw.
I'll set them right click on it.
So let's draw a unit circle. This is our circle, right? And let's draw a center to. Okay, wait. Yeah, let's call this a radius. Yeah. So radius is equals to 1 unit. Yeah. So equation a circle. Okay, let me just draw a Cartesian plane on top of the circle. Yeah. So this is our Cartesian plane. It's not up to scale, but take as the center as like origin. So then this will be -1, right? So equation is circle if this is y axis, x axis. So equation is circle it's given by the following equation: x squared plus y squared equals to r squared. So what does this equation actually mean? We can take any point that lies on the circumference. Let's take this point and call it x1 and y1. Right. So now we have to check, does the following point lie on the circumference? I mean, of course it does lie on the circumference as we have drawn, but now we have to verify whether does it actually lie on the circumference without us having to actually see it by perceiving. So how do we verify that? So we take as points x1 or y1, right? X1, you basically substitute as a coordinates right into your equation, y1 squared. And if your coordinates x1 and y1 do lie on the circumference, this sum of two squares should be equal to r squared, right? So if then this is confirmed by 1 squared plus y1 squared is equals to r squared, then that does confirm that our point lies on the circumference, right? Let's just take, for example, let me just redraw a unit circle here too, but still it won't be up to scale, but I'll just try. Goodness.
Cover and click.
Okay.
0 verse. Ne?
So this is our Cartesian plane. Right, and now let's draw a circle here. Huh? Right, so this is our circle. Right. So let's say upper, it's upper is x is 1. So that means E radius, here circle here too, is 1 units, 1 unit. Right. Yeah? So let's just take any y value that is less than 1 and greater than -1. Let's take 0.5. Let's say ulapha ne 0.5 ne. So upper OY way2 is equal to 0.5 units. So the question would be then, like, what is the x value at this point, at this coordinate, at this point? Ne? So how then do we solve for x? Right, we have equation of a circle here, which is basically Pythagoras. X squared plus y squared equals to r squared. Right. So now we have y and r as the knowns there to the only unknown we don't have in x squared. So solve for x, right? Very simple. So x squared is equals to r squared minus y squared, which is 1 squared minus 0.5 squared. Put me answer yakho ingu okay, let's calculate 0.5 squared 0.25 ne? Wait ne? So it's 1 minus 0.25, which is 0.75. And then we solve for x, right? We take the square root inverse of a square, it's a square root. So x way 2 shia ingu, let me take okay, no. 0.75, it's 0.87, up rounded off to the nearest hundredths. So 0.87, right? But careful, it's also let me just show you something what I mean. Upper nalapha on this point, i-value ka-y ngula 0.5, ne? But now the x values of these 2 points are different, right? They are different. So at this point, x value is not to 0.87, as we can see, but it lies on the negative x side. So it can't be a positive 0.87. So what is it? Ne? So see a notion about, okay, now I'll just teach you a very important concept about roots, right? Yeah. Umzekelo, ne? A solution to the following problem, ne? Let's call it 2x squared is equals to y. Ne? The solution of such problems, ne, is such that, ne, x with 2 is equals to plus minus square root of y. Ne? Why is that case? In plus minus, ne? So it means it's either plus square root y or minus square root y, right? Because now let's take the following: x squared is equals to 9. Ne? So so a naive person would think, but the following solution of this problem is square root 9 equals to 3. But this solution, it's not in full. There's still some information missing. Yes, we do agree that 3 squared is equals to 9.
I'm still fine the text.
Yeah. So 3 squared, yeah, it is 9. But now, how about minus 3 squared? Isn't it 9 now? Answer your corner. Because remember now, a negative multiplied by a negative equates to a positive. So a solution set of this problem, x squared is equals to 9, is that x is equals to 3 or x is equals to negative 3, right? Yeah. So remember this. Ne? The solution of such equation, ne? It results in 2 solutions: the positive solution and the negative solution, right? So yeah. So my point was, before we are up, so just wrap this off. I'm getting used to it. So okay, let's just redraw our Cartesian plane. Yeah. So bensacho. So the answer lapha, it's not only 0.87, but but ngu x squared, ne? But it's actually x is equals to plus minus square root 0.75, ne? Which gives you two solutions. Minus 0.87 and positive 0.87, right? Now remember, so our initial problem was to find a value of x, ne, given y is equals to 0.5 unit. So we have solved our equation, and it gave us two solutions. Solution of this point and solution to this point. Ne? So up to negative 0.87, up to 0.87. So it's negative 0.87, no 0.5. Up to positive 0.87, no 0.5. Ne? So yeah, so that was the introduction to a unit circle. Basically, to summarize what unit circle is a circle with a radius of 1 unit. Ne? Radius of 1 unit. Yeah, so basically equation of circle is Pythagoras theorem, yeah, which is x squared plus y squared equals to r squared. R squared the radius, x no y are the coordinates, ne, that lies on the circumference. If you take a point that lies outside the circumference, it won't necessarily be true for this equation. So therefore that means that point does not lie on the circumference. For any point that lies with circumference here too, it has to respect the equation, ne? If you take this point so this has to be y is equals to 1, since y intercept, and we know at the y-axis our x value is 0. So therefore, in order for this equation to hold true, a value of y can only be 1. Right. Moving on, we're gonna cover trig identities. Right. So trigonometry has identities as as coordinates, but there are a handful of them. So let's just write tower. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, then tangent is opposite over adjacent, right? So this is our mnemonic. Can't pronounce the word, but it's mnemonic. Let me just write it down. Mnemonic. Yeah, mnemonic. A very good way to about what does sine, cos, and tangent mean. So one very famous or rather important relationship here trigonometry is the equation of a tangent. So tan, we know tan theta is equals to opposite over hypotenuse. Okay, let me just draw a triangle here, right angle triangle. Call this theta. So this is the hypotenuse, this is the adjacent side, and this is the opposite side in respect with theta, which is our angle of reference. So this is not, it's opposite over adjacent, right? Opposite over adjacent. So katoa, tan is opposite over adjacent, right? O over A. So it's a relationship yet, or like how does it come about? So let's take sine. We know sine is opposite over hypotenuse. Then cos is adjacent over hypotenuse. Right, so let me show you a very slight trick. If we take sine theta, same divided by cos theta, so this will result in opposite over hypotenuse divided by adjacent over hypotenuse. So you know a laws of algebra, or divide by, or divide the fraction, this chain if you try and simulate it changes to multiplication, then linear be inverted like this, h over a, so it be in this form, right? So we see we have h on both sides, which can cancel each other. So opposite over adjacent. So sine theta over cos theta is actually equal to opposite over adjacent. But now look at this interesting results. Opposite over hypotenuse, over adjacent with tengubani, tan theta, right? So therefore, this equates to tan theta weight, right? So sine theta over cos theta is actually equal to tan theta. So this is one derivation of tan theta. Two of this is the quotient relationship. IB's quotient, quotient rule or relationship, can call it whatever you like, right? Moving on to another relationship, the trigonometry, one of the useful relationships that I find them useful. So yeah, kubekho le Okay, Hlonela, it's only now I'm taking note of a message yakho. Okay, but because we have already prepared for a trigonometry, so we are trying to follow a structure as Chile, so that we know like what topics we have covered. Yeah, but because now we don't want to dwell with topic A1, but rather we want to follow a structure that is a concrete, right? But if you really want to do Euclidean circle theorems, I don't know, maybe we can offer you like a one-on-one session or anything, you understand? But I mean, you can communicate that with Ubuluvuyo, then he'll let me know on. But what we are doing, Tina, as of now, we are trying to follow the structure, and the structure say to now city we are covering a trigonometry, ne? Yeah, and we will cover a circle geometry like during the week or during the course of this stream thing, you understand? But as of now, we are still covering a trigonometry, and don't worry, we will drill a Euclidean geometry course such that you understand it thoroughly. But as of now, try to 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 be with us with trigonometry, because now what we have analyzed that out of 12 questions go paper 2 grade 11, there are about 5 questions that are dedicated or rather related to a trigonometry. So trigonometry does plays like takes a huge chunk of a mark Chile overall. I think it takes around like almost 30% of your entire mark. So trigonometry, yeah, it's important, and it's a topic it needs. Hence, I want to first cover it as soon as possible. And according to a curriculum grade 11, it's only now that you are starting to cover a trigonometric term 2. So yeah, that's that. So moving on to a second relationship, trigonometry. So we have this important relationship called sine squared plus cos squared theta equals to 1. So we have layer relationship, ne? So is this true? Okay, let's try to prove that it is true. We're gonna use our unit circle, right? Okay, let me just redraw unit circle once more. Okay, promise this is for the last time I'm drawing a unit circle. So this is the unit circle here, right? Right, so this is a unit circle here, right? Let's just draw a simple vector. Simple vector, right, that points at this, and upper, let's call this theta, right? So, and this is of unit 1, radius of unit 1. So a length of a vector A2 is unit 1, so is equals to 1. So we know most sine theta V2 bar is sine theta is opposite over hypotenuse, and cos theta is adjacent over hypotenuse, right? Okay, let's just rather use linear this. So sine squared plus cos squared equals to opposite over hypotenuse squared plus a over h squared, which equals to o squared over h squared plus a squared over h squared, which equals to which equals to h squared over opposite squared plus adjacent squared. But now let's go back to our triangle that we drew, right? Ne? So if we are drawing up a triangle, so Pythagoras, OT, we're gonna use this triangle. O squared plus a squared, ne, is equals to h squared. So this is Pythagoras theorem. Opposite squared plus adjacent squared is equals to hypotenuse squared, right? So nalapha now. So now OA squared plus A squared is equals to H squared. So we can now substitute upper lindawo sibeke H squared over H squared. Okay. Right, that is squared, guys. So h squared over h squared is what? It's equals to 1. So we have seen that indeed sine squared theta plus cos squared theta is equals to 1. Ne? So we have covered two important identities. Sine squared theta plus cos squared theta is equals to 1. Tan theta is equals to sine theta over cos theta. So moving to a third relationship, right? Third relationship. Yeah, which is okay. Does a grade 11 cover what compound angles? Hlonela does a grade 11 cover compounded angles in the sine 2 theta cos 2 theta. Have you covered Londo Kanye does grade 11 cover Londo, but let me just rather search. Okay, it does cover. Okay, so we're gonna do one of the important relationships, the compound angle. So sine 2 theta, right? Yeah, now this is equal to what? If you want to, okay, it's already in simplified form, but if you want to expand it, so it results into sine theta cos theta. So sine 2 theta is equals to 2 sine theta times cos theta. Ne? So I'm not going to prove this equation because it's rather tiresome, but take it as it is. Perhaps you're gonna cover a proof here tomorrow. Then it's been cos 2 theta. Yeah, now with cos 2 theta, it's equals to 2 sine squared theta minus 1 phinde be equal to 1 minus 2 cos theta. Is it like this? Okay. No, I think it's not like this. This is actually cos instead of sine. So nalapha it's actually sine instead of cos. So understand okay the beta nisila for some reason. So we have this following relationship: 2 cos 2 theta, no 1 minus 2 sine squared theta. So we have covered 4 what you call identities of a trigonometry. So which the first one is a tangent quotient or a quotient rule, which is tan theta is equal to sine theta over cos theta. And the second one is that 2 sine squared theta plus cos squared theta is equals to 1. The compound angle Z. So okay, for these two I will prove them to you tomorrow. Right. So these are the top four important identities, say trigonometry. I mean, there are other identities that you can derive from as identities that we have covered. Yeah, but for now, so basically, pillar up with regards with the identities. So what I'm gonna do now is I'm going to cover a trig reductions, right? So let me just write a big trig reduction. Maybe we have it about Twitter's message. Trig reductions. So so let's first draw a Cartesian plane. In Cartesian plane, apecaleni. Cartesian plane. Ne? So and let's draw the following. So this is okay, rather this is not a Cartesian plane, but not a Cartesian plane. Cartesian plane is like xy, but okay, I forgot what is it called, but it's not a Cartesian plane. So 0 degrees up 90 degrees, 180 degrees, 270 degrees, 360 degrees. Right. So so basically the input ska theta weight up, ne? So this is the first Cartesian, second Cartesian, third Cartesian, and fourth Cartesian, right? So do I know all sign? Okay. So we first quadrant, rather not Cartesian. First quadrant. Ne? Upper ne? Utata like if you look at theta to be between 0 degrees and 90 degrees up, and then plug them into either of your trig functions, be it sine theta, cos theta, or tan theta. Your values will be greater than 0, ne? For theta between 0 degrees and 90 degrees, they will be either equal to or greater than or 0. So meaning, let's take in any angle between 0 and 90. Let's take 45 degrees. For example, sine of 45 degrees will give you half. No. Sine 45 will equate to, is it half? Okay, I'm not sure. It's either a half or it's something like this. I'm not sure, but point is that the answer yakho will be positive. And alapha can be so same applies nalapha it will be greater than 0 though. For any angle between 0 degrees and 90 degrees in the first quadrant. So the first quadrant is 0 degrees, 90 degrees. Right. Moving on to a second quadrant. Ne? Second quad, theta is an element of of 90 degrees to 180 degrees. Right. So things are a bit different. The only positive trig function upper second quad sine. So what do I mean by that? Take cosine and then take any value of theta that is between 90 degrees and 180 degrees. Value yakho will be positive. Will be positive, not greater than 1. Positive means greater than 0. Will be positive, right? Meaning sine theta wako will be greater than or equal to 0. Any other trig function will be less than 0. Will be less or equals to 0. So the only one that is positive is sine theta on the second quad. Let's make an example. Let's take sine 100 degrees. Sine 100 degrees equals to what? I'm sure it will be positive. Sine 100 is 0.98 for what is 0.98 what. And let's take cos 100. So we are expecting cos 100 degrees to be less than or equal to 0. So indeed it is less than 0, so negative 0.17. Same applies naku tan cos 100. We are expecting it to be less than 0. So minus 5.67. So we do indeed see that 7, we do see indeed that cos 100 way 2, no, tan 100, they are less than O0, right? So less than O0, okay, not 5 points, whatever. So they are less than O0, right? But I mean, we don't have to go to a calculator to actually see that are they less than O0 or greater than O0. We can just draw a graph Z, trig function Z. Let me just draw one now, just show you something interesting. Yeah. I hope they won't overlap. Okay, so let's first draw like a sign, right? So sama saya trig graph ka sign, it's something like this, right? Something like this. Eka cos, it's probably anyukan. Anyukan yas. Oh, iqala kuphezulu kanye iqala ku-1. Ikhona into wrong. So iqala apha ku-1. Be something like this, ne? And then eka tangent, ne? Just draw something like this, but something like this. So upper, you know, upper 90. Upper 180. Then upper 360. So if siyajonga we first quadrant yethu, ne? So the very between O0 to 90, ne? So okay, let me just write this off like a tangent here, BT for some reason. So if siyajonga, so besithi first quadrant is 0 degrees to 90 degrees. So if siyajonga, ne, between 0 degrees and 90 degrees, y value yethu ka sin theta, it's above 0, meaning it's positive, right? Same applies nalapha ku cos, ne, between 0 degrees and 90 degrees is above 0, so it's positive, ne? But now, as soon as you move to the second quadrant, meaning 0 degrees to 180 degrees, we then see that yes, now EY value ka sin theta, it is still positive as it lies above x-axis here too. But however, for eka cos, now it's starting to drop down below x-axis here too. So it's starting to become negative. So now we can see that upper graph here to that on the second quadrant, cos theta way 2 is indeed less than 0 degrees. I mean 0. It's less than 0 on the second quadrant. Ne. So moving on to the third quadrant. It's basically somewhere here, so 270. So let's check. So third quadrant here, it's 180 to 270, third quadrant. So now on this quadrant, ne, on this quadrant, sine wethu is starting to be negative naye, right? Starting to be negative naye. Yeah, now this is 180 degrees, right? So now it's starting to fall, graph here is starting to fall below the axis here too, with that quadrant here too. So it's negative, yeah. So upper sine wethu is negative. Same applies now to cos. Cos use negative with that quadrant. Yeah, now for cos only begins to positive once theta wethu is above 270 degrees, but less than 360 degrees. So meaning this is the fourth quadrant. So now we fourth quadrant here too. Cos theta, it is positive. Yeah, now sine theta, set negative. Graph still lies below x axis. So this is the third quadrant. Yeah. So I mean, you can see that the land, it can be depicted from a graph z functions there to that is cos theta, sine theta, tan theta positive or negative on which quadrant. So this graph will tell you between which angles is sine theta positive or negative. So yeah, so you don't necessarily have to type it down with calculator to actually see whether tan theta or cos theta is it positive given an angle. You can simply draw your standard graphs and check which quad does theta lies on, then you will then know so sine theta on this quad is positive or negative, right? So now see we reductions into answer anyway. So we have the very first reduction between sine theta and cos theta. Sine
18.
Okay. So sine theta wethu reduction yakhona yokuqala is cos equals to 90 degrees minus theta and vice versa. Cos theta wethu is equals to sine theta. Wait, it's not sine theta. Sine 90 minus theta. So okay, this I can prove this fairly easily and straightforward, but now you have to follow. So let's draw a graph set once again now on different planes. Let's first draw a sine. Draw a sine. Wait. So sine, we know it's straightforward. It's even easy to draw. Yeah. Okay, something different now begins. goes on and on and on and on. So this is sine theta. So this is theta. So let's draw eka cos. Let's draw eka cos, a graph ka cos. Let's draw eka cos, yes. Yeah. So eka cos is sort of hard to draw for some reason. No. So this is like a cos, right? Right. So let's draw our angles. So this is 90, 180, 270, 360. So let me show you something. Let me just show you a very useful trick.
Empty.
Let me just read.
Start with 10 or right click now.
Yeah. Just show you something interesting. So up on minus 90. Minus 90 degrees. So it's going on and on. So if we shift the graph ka cos, remember this is, let me just write it down. This is cos theta. So if we shift the graph ka cos theta 90 degrees, so if meaning sithatha le y axis yethu shift like 290 degrees, shift to upper, shifted to up. And then let me just remove the x-intercept. So you can see now the graph ka cos theta, if we shift the y-axis here to see negative 90 degrees, it's starting to look like eka sine theta rather than eka cos theta, because now remember, upper to 0. Let's go up above. So don't these two graphs look the same now? Or rather look the same. They look the same indeed. So what we did, we took y axis here to ibilapa here, so oh my goodness, okay, ibilapa, so I shift to the left to negative 90 degrees. Now a graph here too, it's no longer cos theta, it is sine theta. Yeah. So now this is no longer a graph cos theta, but rather eka sine theta. So if we do the same nalapha, upper kuleka sine theta, see shift our y axis, see shift like by 90 degrees, see upper, see upper, see upper. Let me remove lena now cos. So yeah, now we are born now lena ka sine theta. It begins to resemble a graph ka cos theta instead of a sine theta. So this is no longer a sine theta graph, but rather a what? Correct, a cos theta graph. So from what I've done, we can now see that indeed sine theta v2 is equals to what? Cos 90 degrees minus theta. Right. So this is one way to prove our trig reduction. So what I've done, I just shifted y axis here to 90 degrees to the left or 90 degrees to the right. And the two graphs started to sort of like change, like vice versa, like starting to invert. Ne? Right, so this is one trig reduction, that to sine theta is equals to cos 90 degrees minus theta. Right, so this is one. So let's do another trig reduction. So another trig reduction is that sine now it's 180 plus theta, right? Equals to ubani. Okay, this is question mark. Okay, now I haven't crammed this reduction, but we can prove it to see, but like what does it equals to? So let's just refer back to our graph. Okay, I'll just use this. Let me just clear the flowing. Okay, this is sine, right? So 180 plus theta, so that means we shift 180 degrees to the right. So we're gonna shift this y-axis 180 degrees to the right. So let's do that and see. Like, so this is a sine graph, like this is sine theta. But now, as you see, shift 180 degrees to the right, like a graph kaban. So now let's take this as our y-axis and this as 180 degrees. So a funny thing happens, right? So let's look. So we have shifted y-axis here. But now look careful. I'll just redraw a graph ka sine theta up. You're gonna see something very funny is happening. I'm gonna draw a graph ka sine theta. So let's take this as 0 degrees instead of 180, and this is 90 degrees. this is 180 and so forth, right? But now look at the graph, which graph, which graph does it resemble? Just look at it careful. Doesn't it resemble a, let me say 90, okay, wait, pounds, and that's beat up. Okay, so I have shifted the graph here, 270 degrees rather than, okay, sorry guys. So we have shifted the x-axis here to by the wrong amount of the angles. So let me just fix what I've just done. So okay. Oh yeah, so that is why I've been beta killed. So let me just wrap this up. Okay, so apha ibingu 0 and 90, so this is 180. So yeah guys, so yeah, so I've shifted EY axis here to 180 degrees to the right. So now let's look up if you wanna know. Now look at this. Look at the following two graphs. Lena ka sine theta, na Lena, starting from this y-axis. Do you now see that starting from upper, wait, this looks like an inverted sine graph. Now upper iyehla, then xa ifika upper then inyuka. But upper ka sine, instead of iyehla, iyanyuka, then xa ifika upper ihle. But lena xa ifika upper, so this is 90 degrees by the way. 90 degrees, let me just write that down. Let me just write that down. This is 90 degrees, so same applies now. So graph here to like upper, like yes, then if you go 90 degrees, is still negative by the way. Upper if you go 90 degrees, yes, if you go up 270. Upper at this point, then ibe ngoninyukayo, but lena xa ifika ku 270 ayinyuki, rather iyehla. So you see that these two graphs are the same graph, but they are inverted. It's you almost like inverte lena, y-gweta like y-10, y-10 like upside down. Exactly. So lena this, yeah, so in Joma Sado, sorry if I pronounce your name wrong, you are indeed correct. So when we have added, when we have shifted EY axis here to by 180 degrees now, lena it becomes a negative sine graph, ne? And I hope the way I have proved this reduction, it makes sense, right? So this is like a sine graph, sine theta. Now we then shifted EY axis here to 180 degrees, but now it sort of resembled a inverted sine graph, since I sine graph here to inyuka, this one yehla, and our sine graph here to in isihla leni yenyuka. So it is indeed, as Ujoma says, that sine 180 plus theta it equals to minus sine theta. So this is our second trig reduction that we have covered, and I hope the way I have proved it, that it makes sense and it's clear to everyone. So is it clear? Let me confirm. Is it clear that the way I have proved these reductions, do they make sense? Are they understandable? Okay, so let's move on for the last trig reduction of the day. We're gonna stop at 8 for today, since we began late, but I promise tomorrow we will begin just after 5 till probably 7:30. So we're gonna have tomorrow like half 2 hour session to 3 hour session. Our last trig reduction for the day, ngeka cos. So let's do cos. So ngibheka cos. Cos okay, I'm gonna do the same. Cos 180 degrees plus theta. Yeah, now like what does it simplify to? Let's prove it now. We're gonna prove it the same way we have proven like the second reduction. Now we're gonna just write our graph. Ne? Then sees Balida cost. So let's start somewhere here. So this is negative 90, right? So it goes cos somewhere like this. Then it goes on and on. Okay, let me just redraw this because it's imby. Yeah, much better. Yeah, it's much better. So this is O cos theta. So this is 90, this is 180. I'll just drop this off. So we're gonna do the same now. We're gonna shift our y-axis rather, to 180 and see, like how does our graph look like or resemble. Okay, I'll just answer it now. So let's take it as if a graph here to this is our y-axis for our graph. So if you see, now we have shifted y-axis here too. Now let's take this as 0 degrees, 90 degrees, so on and so forth. Right. But now something similar is happening to a trig reduction ka sine 180 degrees plus theta. Now if we starting to look our graph from this point onward, we now begin to see that the graph here is starting to resemble as in inverted graph eka cos. Why? Let me just show you why.
One question.
Okay, if it's 3 cos x, the limits are going to be from -3 to 3. Okay, so now when Joma, you are touching upon different what you call definition. You are starting to talk about limits, but limits, as I know, the limits go grade 12, but by limits I think you mean e amplitude rather than e limit. So we have e amplitude. Let me just cover Joma first. Okay, so let me just do this real quick. Okay, given an equation, Joma, just see up. So this is O, okay, rather a sine x, right? So O 3 cos. Okay, let me just write 3 cos as you have written. So this value of OA, it's called amplitude. It's not a limit, because when you are talking about limit, you are talking about a different concept. So, so this is called amplitude of our graph instead of a limit. Let me just draw this right. So our graph would stretch in proportion to this value of OA. So in your case, it is 3, right? So our graph will look something like this. Okay, let me just look across. Will look something like this. Where up this is 3, and here it's -3, but with if our cos graph is not stretched, it will look something like this. Okay, it will be something like this. Okay. It will be something like this. Something like this, but the point is, it will be, its amplitude will be of less. So this is +1. This is -1. So amplitude stretches our initial graph. So it stretches this by the factor of a. So if a is less than 1, so it won't stretch it, but rather it will compress it. But now if it's more than 1, it will stretch it with respect to the value of a weight. The constant changes the amplitude value. Yes, the constant does changes the amplitude value. So tomorrow we'll be covering those concepts, the amplitude, the periods, the what you call this, the shifts, the what, all those jargon words that are found with trigonometry. So we'll cover them tomorrow, but for now, we'll just cover this. So where I was, I hope I did answer your question, if it was a question. Yeah, it's my pleasure. It's my pleasure. It's my pleasure. It's my pleasure. It's amplitude, not limit. Use the right words. When you talk about limits, you are talking about a different concept of maths that is found on calculus topic. Right. Okay. So this lab. So now I've shifted my y-axis 180 degrees to the right. Now let's look at, okay, I was drawing graphical cos. So look at this graphical cos, right? Now look at this. Let's take it as if the graph starts here. May ignore this side, just focus on this side. So here the value of our graph at this point, excuse me, sorry, it's -1. But upper it is +1. And from here onward, this graph iyanyuka. Its tangent is increasing. So kuthiwa when you fika grade 12, a point of inflection, right? Point of inflection, grade 12, no?
What about the point of inflection?
Point of inflection, like
Oh yeah.
Yeah. So a point of inflection, it's a topic covered in grade 12. So upper a gradient of our tangent is increasing, but as of upper iyehla. And I figure like I cross the x-axis, it's less than negative. It's less than 0, so it's negative. But for here, I cross the x-axis, it's becoming positive. So nalapa, this graph is depicting an inverted graph cos, literally. So this then means that cos 180 degrees naye is indeed equal to a negative of cos theta. So enye xa inyuka enye iyehla. So we have covered three reductions. So tomorrow we're gonna start from this point of three reductions A2. So yeah. So let's just summarize the lecture of today. So what we have covered. So we started with a unit circle, rather. So we said that a unit circle is a circle of radius equals to 1, right? Or rather equals to 1 unit. And we know that equation of our circle is given by the Pythagoras equation, which is x squared plus y squared equals to r squared. Then we said that any point that lies on the circumference of the circle has to respect this fundamental equation. If you take this point here, x1, no y1, when you substitute them into this equation, their sum of their squares should equals to a square number of the radius, right? And then we move on to solve x. So we had the following problem. So we took any point on the circumference and we made y corner to be equals to 0.5 unit. So we took these 2 points here, and then we solved for x values of these 2 points. So we know radius that is equals to 1, and we are given that the value of y is 0.5. Then we went upon to solve for a value x. Then upon that, we find out that Ux is not only equals to one value but two, because why? When you take a square root to be specific, not just any root, when you take a square root of a number, the resulting result, it will be a positive and a negative number. And we made an example of x squared equals to 9 squared. Let me just repeat that. So we said the following: x squared equals to 9. And one would say that this is the solution of this equation. But now, this is not wrong, but it is not entirely correct. Because now, what about negative 3 multiplied by negative 3? 9 equals to 9. But now on our equation, we did not incorporate the answer negative 3. We only included 3. So, therefore, a solution of such equation, x squared equals to y. So x is equals to plus minus square root 9, square root y rather. So in case of 9, so this will be plus or minus 3, right? So then when we solved when we solved our equation, we then find that it gives us a point x on this point, a value x on this point, and also, oh my god, and also a value x on this point, since these 2 points share the same y value, which is equals to 0.5. However, they share a different x values, which is alena is negative 0.87, and for this one it is 0.87. And then we went on to cover trig identities. One trig identity that is very important is a quotient rule. So quotient rule is basically sine theta over theta. So a quotient means is divide, product, multiplication, sum, addition, difference, subtraction. So yeah, so sine theta divided by cos theta is equals to what? Tan theta. And then we went on to prove this identity of sine squared theta plus cos squared theta, and then we solved it, and then we did find out that indeed this identity equals to 1. Then we went on to cover a compound angles, of which I did not provide the proof for these identities because the proof yakona is rather long, but I'll try to prove them tomorrow. And then we went on to cover only 3 reductions: first quadrant, second quadrant, third quadrant, fourth quadrant. First quadrant, all our trig functions are positive. Sine of 45 degrees is greater than 0, cos of 45 degrees is greater than 0, tan of 45 degrees greater than 0. But for the second quadrant, only sine theta that is positive, right? So a sine of 100 degrees, how 100 degrees is between 90 degrees and 180 degrees. So sine 100 degrees, we then verified that it is indeed greater than 0. But then when we checked for cos of 100 degrees and tan of 100 degrees, we noticed that if values are corner, they are less than 0. Then on the third quadrant, only tan theta that is positive. So cos theta and sine theta of the third quadrant, they are less than 0, so they are negative. And then we moved on to the last quadrant, which is 270 degrees to 360 degrees. And then on this quadrant, only cos theta that is greater than 0. So sine theta and tan theta, both of them are less than 0 degrees. 0. And then we went on to prove our trig reductions. So yeah, that is it for today. So tomorrow, probably we're gonna start at 5. We're gonna continue from this point onwards. Gonna cover more trig problems and trig concepts. So trigonometry is a very important part of math. It is very applicable on real life problems. So yeah, it's one of fundamental topics in maths. So covering it as one of the very first topics is very important, as it takes like a huge part of a year maths. Around about 30% of your mark year maths is coming from trig topics. So thank you for attending. We will see you tomorrow, like harmonic trigonometry. Okay, Joma. I will consider your request, harmonic trigonometry, and see how I can fit it into our structural approach. So yeah, I will consider that and see if I can just put it in on tomorrow's topics. So yeah, thank you for attending. I hope you'll be attending even tomorrow. So that is it for today. So bye bye. Thank you. Ciao.